Hello everyone, welcome back. Today I am going to do Unit 4 of Class 7, that is Air. Firstly, the composition of atmosphere. As we know, nitrogen is a 78% and oxygen is 21% and rest are the other gases in small amounts. Now, if we go a little deeper, you should also know about nitrogen fixation and which gases are most in quantity. In order of abundance, air has nitrogen first and then comes oxygen and then argon, then carbon dioxide, neon, helium, krypton, xenon, and finally hydrogen. Okay, and now let's talk about nitrogen fixation. For example, in bacteria live on the soil and in the roots of some plants. These bacteria take nitrogen from the air and convert it into a form that plants can use. In the soil, nitrogen is converted into nitrate, which plants absorb. So the nitrogen bacteria help bring nitrogen from the air down to the earth and make it available for plants. That's how nitrogen fixation works. Okay. Next, we come to the structure of the atmosphere, which is quite important. Okay, the first layer is troposphere. The average height is about 13 kilometers, and this is where the air we breathe exists. Okay, here is something interesting. Suppose this is a surface, and this is the equator region, and these are poles. Okay, the average height of the troposphere in equator is 13 kilometers. Okay, but in the polar region, it is not thicker as in the equator. Maybe it may be around 8 kilometers in polar region. But why? At the equator, the sun's insolation is very high, right? The sun's insolation is very high. So the air becomes warm. In this region, the air becomes warm because the surface is heated. When the air becomes warm, it will rises. Okay, this movement we call it as convection. Because of the strong upward movement, the troposphere is thicker near the equator. And also in the poles, the temperature is lower, right? So the air does not rise much. That's why the troposphere is thinner here. You can wonder about the Sahara Desert and the Himalaya. They are nearly on the same latitude and also almost in the same line. But look at the difference. Sahara is very hot and while in Himalayas are cool. Why is that? Well, the Himalayas are at a much higher altitude and so naturally they have cooler weather. And this brings us to an important point you should always remember. That is when altitude increases, temperature decreases. Okay, now another interesting question. Have you ever thought why carbon dioxide is less in upper parts of the atmosphere? Here the simple explanation. That is most of the carbon dioxide is concentrated near the surface. Okay, near the surface. So when shortwave radiation comes from the sun, the lot of it gets absorbed at the ground level because of CO2. That's why there are more heating near the surface. As we go higher, the amount of CO2 decreases. This means less radiation is absorbed and the temperature goes down. In short, as we higher up, there is less carbon dioxide and less heat and there is a cooler air. That's why the air becomes colder as we move up. Okay. Now, let's come to the next layer, that is stratosphere. This layer extends roughly from 18 km to 15 km above the earth. It's almost free from clouds and which makes it ideal for airplanes to fly. But what's really special about this layer is the ozone layer. It protects us from the harmful effects of the sun rays. You might wonder how is ozone formed? Ozone is O3, as you know, right, made from oxygen. In the stratosphere, we have oxygen, that is O2. When sunlight hits O2 molecules, when sunlight hits O2 molecules, it will split into two separate oxygen atoms. Then one of the atoms join with another O2. It will join one of the O2 molecules to form O3, that is ozone. That's how the ozone layer is created and it acts like a shield against harmful ultraviolet rays. So just to compare with the troposphere, in the troposphere as height increases, temperature decreases. But in the stratosphere, the temperature actually increases with the height because the ozone absorbs heat from the sun. Now, let's move to the next layer, that is mesosphere. This layer extends up to the about 80 kilometers above the earth. Okay. And here's something cool. Meteors burn up in this layer when they enter from the space. That's why we see shooting stars. In the mesosphere, there aren't many gases, so it doesn't trap much heat or radiation. That's why the temperature decreases as we go higher. You might think the troposphere is coldest, but actually it isn't. The troposphere blocks some ultraviolet radiation which keeps it warmer, but the mesosphere is very thin and almost still and really cold because there's nothing to absorb heat. Okay, after the mesosphere, it comes to the thermosphere. Here the temperature rises very rapidly as you go higher. A very special part of this layer is ionosphere, which extends roughly to 80 to 400 kilometers, and this layer is extremely important for radio transmission, and signals sent from Earth are reflected back by the ionosphere. So your radio or communication signal can travel very long distances. Without this layer, long distance communication would be nearly impossible. The last uppermost layer of the atmosphere is exosphere. This layer has a very thin air, and the gases here are extremely light, like helium and hydrogen. They are so light that they can slowly escape into space. You can think of the exosphere as a border between Earth and space, where the atmosphere gradually fades into the vacuum of space. Now let's move on the weather and climate. You know, weather is what happens in day by day. Like today it's sunny and tomorrow it rains. Climate is different, means it's the average weather over a long time in space. For example, desert has hot and dry climate, while mountains have the cold climate. Next, the climate temperature, by the way, is simply the degree of hotness or coldness of the air. And when we talk about insolation, we mean the incoming energy from sun. You should know that insolation decreases from the equator towards the poles because the sun rays are more direct at the equator and spread out more at higher latitudes. Now let's talk about the air pressure. The air pressure is basically the weight of the air pressing down on us. At sea level, it's the highest because there is more air about. It means there are more air above pressing down. As we go higher, there's less air above, so pressure decreases rapidly. Also, air pressure changes horizontally depending on temperature of the air at ground level. Warm air rises and creates a low pressure area, and cold air sinks, creating high pressure areas. And remember, air always move from high pressure areas to low pressure areas. Okay. And finally, this movement of air is what we call wind. And wind is simply air moving from high pressure to low pressure. The stronger the difference is pressure, the stronger the wind. This is why we feel breezes near hills, coast, or during storms. The air is always trying to balance the pressure differences. Now here comes this diagram, which is about the major pressure belts and wind system. We will study this in detail in the coming classes. If we go too deep right now, it will take a lot of time. So let me simply explain the main idea. Now you see the arrows in the diagram, right? They are slightly deflected, and that's because of something called Coriolis force. When the air moves, it normally wants to move straight, but the Coriolis force changes its direction slightly. That's why different winds occur in different regions of the earth. We will cover all this in detail in the next class, but for now just remember, permanent winds are those that blow constantly, like westerlies and easterlies, and also seasonal winds means change directions with the seasons, like monsoon winds in India. And local winds happens only during the certain times of day or in specific areas, like the sea breeze during the day or lu in the summer. Now let's talk about the moisture. Moisture is basically water in the air. When the water evaporates from the land or water bodies, it becomes water vapor. The amount of water vapor in the air at any given time is called humidity. When this water vapor rises, it starts to cool. As it cools, the vapor condenses, forming droplets of water, and these droplets eventually lead to rainfall. There are three main types of rainfall, that is conventional, orographic, and cyclonic. Let me explain each one the way I always explain it. Now, look at here. The convectional rainfall. Imagine this is a surface near the equator where the sun rays very strong and insulation is high. The surface heats the air above it, right? The warm, moist air rises because hot air is lighter. And as it rises, it cools down and the water vapor in it condenses to form clouds. So when condensation continues, rain falls, and this is what called convectional rainfall. Means when suppose this is the air, moist air coming in this direction, you know, in the equator region there is a high heat, right? When it meets the high heat, it will rises, right? When it rises, it forms here the cloud, and there is a precipitations will occur. Okay, this is how the conventional rainfall will form. Now next is orographic rainfall. Now imagine the moist air from the ocean moving towards the mountain. When this warm moist wind hits the mountain, it is forced to rise along the slope. As it rises, the air cools, right? Water vapor condenses and rainfall on the windward side of the mountain. After crossing the peak, the air descends on the leeward side, becomes dry, and that region often receives very little rain. So orographic rainfall is basically rain caused by mountains forcing moist air to rise. Okay. we have cyclonic rainfall. This happens when warm air and cold air meets. The warm air is forced to rise over the cold air, cools down, and condenses and rainfall occur. Cyclonic rainfall is usually associated with storms and thunderstorms. And don't worry if all this feels a little complicated. We will cover these types of rainfall in more detail in next coming classes. And that's it for today. Thank you so much for watching this video. I will upload the next video very soon, and don't forget to like, share, and subscribe to my channel.